Okay, so in this video, we are moving on to classes. So object-oriented programming, abstract data type, these are all concepts that we are going to start covering from this chapter. We've already started doing some of those things with structs. So what is object-oriented programming? So the objectives would be to define object-oriented programming, object state versus object behavior. What does all that mean? Define the difference between a class and an instance, define a client, and create a first class instances and client. Those are all the things that we'll be doing. So what is object-oriented programming? It's very simply trying to treat a program as a set of objects rather than actions. So you've already seen that we have done this with our video object. We've seen examples of your song database. A song is an object. It has attributes. You can do things with it. Likewise, a video is an object. It has attributes, which was my title and year. We are going to keep using that. And the methods that we could do with it, for example, print a video. You also saw how to add videos to a list, likewise add songs to a list. Same thing with cars. So we treat them as objects, and the methods or the actions that these objects can do. So examples are objects in the room, right? And in life. So think about it in an object oriented way is to take it and treat it as an object, and which has attributes and which has methods that go with it. So for example, a table. If you look at a table, what is the common data that goes with it? So you want to think about some of these things. What is common that is part of the table is different for each table. So the length, the width, the height, the depth, things like that, the color, these are all common to the table. They're just different for each table, right? So if you think of a table, and if you try to convert that into a class, a data type in a program, you would create a class called table. It has a height, width, and depth. You could add more things to it, but to start with, these would be our data members. You could add color to it, perhaps, right? Number of legs to support it, or whatever. So different attributes of the table. Likewise, here's an example of a car. The car has different colors, different names, different make, different model, and so many other attributes like the horsepower, the speed, depending on whether it's a sports model or a convertible. So if you take a car class, you could have a car name, which is a char array, the make, again, is a char array, a model, an int, the odometer, which is an int, and a Boolean variable is convertible. So different ways to define an object. This is what we are going to talk about in this phase of our class that we're doing. So object-oriented design it's essentially a problem-solving methodology that helps us define things as objects. It combines the data and operations. That's a very important concept. The data and the operations on that data in a single unit. So the title and the year and what you do with it is all part of the object. So the print, for example, is an action that you take on the object. The print doesn't hang by itself. The print is part of the object. The title is part of the object. The name of your song is part of the object. Adding a song to a database is part of the database object. So you have to think of everything as a single unit depending on what the unit is and what the operations are and what the data is for that particular unit. So a class is a collection of fixed number of components. A member is a component of a class. So the car, this is a class, and all of these members make up that class. And right now here, all we have are data members. Eventually, we will have member functions as well. So it's very similar to the struct that we saw last week. We take it and extend it to a few more things. Okay, so here is a video class we've been working with as my example. So instead of a struct, we take it and make it a class. A class member, which is the data member, can be a variable or a function. So we have two variables, data members, and we have two member functions. Okay, the variables are defined exactly like you did in a struct. The only difference we'll talk about is the private and the public that categorizes the type of these variables. So a class member can be a variable or a function. If it's a variable, you define it like any other variable. You don't initialize it, you declare it. If it's a function, you put it in as a prototype. exactly like a prototype. That's what goes in there. Okay. So function members, here's something to note, can access any member of the class. So set title can access title. Print video can access title, even though it is private. Okay, these are all little things to keep in mind, which we will talk about more as we go through. Abstraction is the concept of separating design details from the usage, separating the logical properties from the implementation details. So if you look at your microwave, you don't really care to see or investigate as to how it operates. All you care about is that you put in the food and it heats it up. Okay, that's abstraction. The details of how it heats it up is abstract to you, right? But as a programmer, you would implement the details, but the client doesn't really care about the implementation part of it. For example, right now you're working on the song database, you've done two phases. You see, the outcome is exactly the same. The same with your assessment. You've done two assessments or you're working on the second assessment. The outcome as to what it prints and what it does is the same. You add songs, you print songs, you search in song list, but the way it is modeled internally between project one and project two is different. Project one is made with arrays, parallel arrays. Project two is made with structs. Project three will be done with classes. So the client doesn't care. The implementation details will change. So that idea of separating the implementation details from the client is called abstraction. Okay, so an abstract data type is a data type that separates the logical properties. So in Java, this is called class, and C++ as well. The fields or members are the values belonging to that data type. And then you have a set of methods on the fields. Okay, so in this class, for example, this is the whole class. This is the abstract data type. It's called video. It's a class. You have members and you have member functions, and then the implementation. And then the client pretty much uses this. Okay. So that is essentially the concept of abstraction. Think about it a little bit more. Hiding the implementation details. So you have your phone, you have your gadget, whatever it is, you don't really care to see what goes on underneath it. So these are the details. The abstraction is essentially hiding these implementation details, which separates the external view from the internal view. So the client doesn't care to know how you've implemented the song database. Internally, you know that you've implemented using classes or parallel arrays, but for them, it behaves the same way. Okay. Okay, so now to talk about these private, categorical, private and public, right? What does it mean? Private data members cannot be accessed by the client, and you want some of them to be private so things don't get ruined when you have them all as public. So data members, for the most part, are private. They cannot be accessed outside the class. Public member is accessible outside of the class. Okay, and protected is very similar to private, but it can be accessed in child classes. So this is important when we talk about inheritance. At this point in time, we won't worry about that. We are more concerned about private and public. So a private data member in this example cannot be accessed by anybody outside of this class. The functions of the class can access them. The functions are public, so everybody outside can access the functions. So everybody outside can access these data members through the functions, not directly as to the data members themselves. Okay, so we'll see more of these as we go through. Private fields. So private says it's a private data field. No code outside the class can access or change it. Client code sees an error when accessing private fields. So when you declare private fields, we'll see how to access them. And some of you have already seen these, accessors and mutators. As the name suggests, accessors are functions that just get information. They're called getters. Mutators are the ones that actually change or mutate the values, and so they're called setters. Since we cannot access these private data members, wherever that my class is, right there. Since we cannot access these private data members directly, we provide functions called mutators and accessors to get them. Okay, so an accessor is a read-only access to the quantity field. So you call the getter get year, it returns year. Remember, this get year is part of the class, so it can access year. So it's like an indirect way of getting the information that you want. That's all it is. Set gets it from you and sets it for that class. Okay, this year and this year have been defined, if you remember, right here, this year. and the title the same way. So we would write accessor and mutator functions for all our data members. So one of the goals of this phase is for you to be able to declare private data members for your class and to be able to write accessors and mutators to access and set all of them. So get year, you would have another one called get title. I should have one for my video class. There's one more called set title that will get a new title and set it. So it's essentially a middleman here, which is the access and mutator functions that does the job of saying, here, let me get it from my class for you because you can't access these private data members directly. And the client code will look like this. avideo.setYear. The a video is from the client side. It will call the setYear function and send a number to it. And setYear takes that number and says, okay, I will assign it to a video's year. A video, remember, is an object, is an instance. It's like the cookie cutter. The class is your cookie cutter, and then you make multiple cookies. A video is one of those cookies. So you send the number to it, setYear takes it and sets it. And then we output it using getYear. Again, you can't output in the client saying avideo.year. It'll say, well, you don't have access to it. So if you call getYear says, okay, here you go, here's the year, and you output it. Okay? So everything is done indirectly. Clients and instances. Once you have your class all set up, you go to your client and create these objects. You can create a bunch of cookies or a bunch of objects of this type of class that you've created. So again, we have done that in structs. We created a video, b video, my video, your video, or a list of videos. So when you declare objects of the class video, each object has its own copy of the member variable's title and year, just like the struct. All of this stuff is the same as the struct. The only difference is that these instance variables now have title and year as private data members, and you don't have access to them from the client side. Okay, and they're also going to have methods associated with them. So the difference between a struct and a class is that you don't specify the visibility in a struct, whether it's public or private, whereas in a class, they are private. And visibility by default goes a little further for inheritance. If you don't specify anything, then the struct will inherit publicly from its base class. Again, we don't get into inheritance in this class at this point in time. So, but you must know that when you declare your class, all of your data members will be private. I do not want any public data members, but all your member functions will be public. So we will define a class like this. For our video class, the constant is the same. You have your class video. These are two private data members. Now you will have 4 private data members for your song database, just to give you an idea, because you have your song name, song artist, minutes and seconds as ints. Then we have constructors. Remember the same kind of constructors that we had for our struct. Constructors work the same way. Same name as our class, same name as the class, different parameters. Default constructor, construct with parameters. The only difference is when we go into classes, we don't put all the implementation in the class. We'll see how to do the implementation outside the class. Other functions, get title and get year. We need accessor functions, mutator functions to set them because they are private data members. We must have these. And of course, one print function to print the video. It's a very simple class. That's all we're doing here. Here's the implementation. Here's how you need to do your implementation for your functions which are outside the class. The prototypes are inside the class, but when you implement them, since they are going outside the class, you would have your class name followed by the scope resolution operator and the name of the constructor. So here's the name of this constructor, is the same name as the name of the class with no parameters. Again, this content is the same. Remember, we have done this before. I don't have a rating, so I will get rid of the rating from here. It's the same thing as you did for a struct constructor. String copy, no title, and quantity or year should be, because I've changed it to 0. Whereas here is the one with the parameters where the parameter coming in gets copied into my existing object's title and the temp year coming in gets copied into my existing object's year. So this is a constructor with parameters. Implementation for our accessor functions that we have defined in our class here. Get title. Make this box bigger, then we can get it all on one line. So again, the name of the class has to be there with the scope resolution operator. Get title pretty much copies the object's title into return title, and since it's a char array coming in, you don't have to return anything. It will automatically go back because it's coming in by reference. Remember, char arrays come in by reference. Get year simply says return the year that belongs to the object. So it's an int type, while this is a void type. So its job is to simply take whose title the object is in scope. So if you say, give me a video's title, it's giving you a video's title. And where do you call that? From your client side. Mutator functions, again, the same way. Set title, it's a void function because the new title coming in gets copied into the existing object's title. So if you say a video.set title within parentheses, you say new title, a video's title will get set to new title. A video's year will get set to new year. Again, what do you call these? In the client. Here's the print function, which simply prints the title and the year. Again, same as your function in the struct. The const here says this particular function cannot change the members. That's what this const means, because there's no reason for us to change these members. Our job is to simply, the print video's job is to simply output these things. So a const says this member function is a const function, which means it cannot change the data members of that class. Here's the client code. The client code that's actually using all of the stuff that we did in classes, right? In this video class. So here's main, temp title. Again, this is just a temporary title for me to read from the file maybe, or wherever from the user. Temp year, char option for whatever I may use it for later on in the program. Right now I'm not using it. Create a video object by passing parameters. It calls the constructor with parameters and creates a single video for me. And I will call this function print video, and it will print its title and year, right? Then I create a B video. This gets created with the default constructor, which means it is not going to have any title. It's not going to have any year. It's going to have something. It'll say no title and year equals 0. So we read from the user into my temp title. Why into my temp title? Because you cannot directly read into B video's title because it's a private data member. So we read into a temp title, and then we read the year into temp year. This is why we need temporary variables, because we cannot directly read into B video's title and year. So we read into temp title from the user, we read into temp year from the user. Then we populate B video by calling the mutator functions. B video.set title. I send temp title to it. It will set its title. B video.set year. Send temp year to it. It will set B video's year. And then B video will call print video function dot print video. Notice how all of these are invoked by the object, which is B video. So the object B video or A video or whatever it is always invokes the method. Keep that in mind. And in my next video, I will show you the code for this.